So looking at the second page here, so considering national abundance information, we got that right here. Calculate the expected number of atoms of each isotope that will be found in a sample of 20 atoms. So, well, the number of atoms have to be a whole number, of course, but it's basically just percentage using these numbers right here. So how many would be magnesium 24 if I had 20 just randomly picked here? So 79% of them are going to be magnesium 24, 10% of them are going to be magnesium 25, and 11 are going to be magnesium 26. So use that as percentage and round it up or down. And so ask if model 1 is accurate in representation of magnesium at the atomic level. Well, then you need to look at percentage of abundance here and then just do the calculation here. Does it seem like the abundance here is at the same numbers as we're going to see here? And then just make your opinion on that. And so if you could pick up a single atom of magnesium and put it on a balance, and so the mass of that atom would most likely be, and then explain your reasoning. Well, I'm going to go ahead and say it should be 24 AMU. Because if I pick out just a single atom, there's a 79% chance that I'm picking up this isotope right here. So I'm just going to go with simple math. It just seems like that's my biggest chance. And so looking at a periodic table, you can just Google that. There's also a really good periodic table, which just P table, the letter P, and then table, one word.com. And then you can find a periodic table to use. And then find the box for magnesium. And so write down the decimal number shown in that box. Does the decimal number shown in the periodic table for magnesium match any of the atomic mass listed in Model 2, etc.? These are the things that you can just research and find. And so the periodic table does not show the atomic mass of every isotope for an element. So explain why this would be impractical. Well, that could be a whole lot of information that you need to squeeze into one little square, and it's not really a particular type of information that you would need at all times or just quick find it in a periodic table. That seems like something that you would need for a few uses, and therefore you can find it somewhere else. And is it important on the average science to have information about a particular isotope? That is kind of a leading question. That is kind of the same question here, just said differently. No, we don't need a particular isotope of every element. We don't need to know that at all times. That will be a whole lot of isotopes. Try to squeeze in. The periodic table is big enough as it is, so that can be stored somewhere else. And what would be a practical way of showing the mass of magnesium atoms on the periodic table? Well, we've already gone through that. We have an average mass. That's what we put there. So we just go through the abundance and then get average mass. And so propose possible way to calculate the average atomic mass out of 100 magnesium. We already done that in previously PDFs, but try to see if you can find a mathematical equation that you would use for that.